Hi, my name is Marcel, and in this video we're going to solve the problem 3 from the exam 1. In this problem we have a physical pendulum which is composed by two masses, a rod and a sphere. And first we are asked to calculate the total inertia, the rotational inertia from all the pendulum in terms of M and L, which M is the mass and L is the length. We need to consider the parallel axis theorem, which says that the inertia is equal to the inertia of the center of mass plus the mass times the squared distance. So we are given the inertia of the rod, the rotational inertia of the rod and of the sphere. The rod one is 1/3 of the mass times the length, the squared length, and from the sphere is 2/5 m times the squared radio. But the radio, as we can see here, is a half of the length, so we can rewrite this as 2/5 of the mass times a half of the length squared. So applying this, we will have that the total inertia is equal to the rod inertia, which is 1/3 of ml squared, plus the inertia of the circle, which is 2/5 m times half of L squared, plus the mass times the distance squared, but the distance is equal to the length, so we will rewrite this as the squared L. And as we can see, we have this ml squared repeating in every term, so we can take this out of all the sum, and we will have that total inertia is equal to 1/3 plus as this. Well, first I will rewrite this as this will be written as L squared over 2 up to the second power is 4 plus ml squared. So now we can take ml out of the sum, and it will be total inertia equal to 1/3 plus 2/5 times 1/4 plus 1. All this multiplied by ml squared. And if we make this sum and multiplication, we will have that the total inertia is equal to 43/30 of ml squared. So now I will erase this, and I will write this in here. The total inertia in terms of M and L will be 43/30 of ml squared. Then we are asked to find the period for a small oscillation of this physical pendulum. So as we can see here, the period for a physical pendulum is 2 pi times the square root of the inertia over the total mass times the gravity times r, which in this case r is the distance from the pivot to the center of mass. So well, if we substitute our values in here, we will have that this is equal to 2 pi times the square root of the inertia, which is 43/30 of ml squared over the total mass, but the total mass is equal to the sum of each mass, and we have that the mass of the sphere is equal to the mass of the rod, so the total mass will be 2m times gravity times the distance from the pivot to the center of mass, which is 3/4 of the length. And if we solve the, well, not solve, but if we simplify this, we will have that the period will be equal to 2 pi times 43/45 times the L, the length, over gravity. So this would be our second case. And I will write it here. It's 2 pi times the square root of 43/45 L over U. And finally, we need to find when the period is equal to 2 seconds, how long should the length be? So, well, having this, the period is equal to 2. And now we just need to solve for L. So this goes, well, this 2 is cancelled. So we will have 1 over pi. As this is the square root, we will raise all this up to the second power. So we will have in this side 1 over p up to the second power equals to 43/45 times L over gravity. And now we just solve for L. That, well, the result of this is 1 over squared pi, and the gravity goes multiplying the 45/2, and the 43 goes dividing. This is equal to the length, and if we solve for the length, well, once we substitute, we will have that the length is equal to 1.04 meters. So this is how you solve this problem. So I hope you understand it. Thanks for watching.